All right, let's spot check number 5. Okay, what'd you get?
5ab to the 4th power c to the 4th.
So what you did is, I'm guessing that you broke this down into the square root of 25 times the square root of a squared times the square root of b to the 8th times the square root of c to the 10th. Okay? I know you didn't, but that's what I bet everybody else did. Okay? All right? Which then, what's the square root of 25? 5. What's the square root of a squared? A. What's the square root of b to the 8th? No, because b to the 4th times b to the 2nd is only b to the 6th. So what is the square root of b to the 8th? B to the 4th. What's the square root of c to the 10th? C to the 5th. But that's not what you said. Is that a big deal? Yeah. Because you know what I mean? If I'm going to, let's say, a doctor and the doctor's one off, that could be kind of a big deal. You know what I mean? So 5a, b to the 4th, c to the 5th is my answer. Now, my question is this. I get the numbers aspect, the perfect square number aspect. I get that. Okay? We got a list of those. Which, by the way, tomorrow on your formative, no calculators, no list. Just so you know, you're going off of, you got a brain, you're going to use it. Okay? Kind of a deal. Okay? All right? So the numbers I'm not worried about. Okay? But what about variables? How do I know when a variable is a perfect square?
And it's like, if you're just squaring it, doesn't 2 have to be able to go into, like, the exponent evenly?
So in this case, it would the exponent would have to be.
I got 6.
Somebody just said it. Even. Okay. So if a variable is a perfect square, it has an even exponent. Okay. Maybe you want to write that down. Okay. But we're not always dealing with just square roots. What if I had a third root, a cube root, if you will? How then do I know if a cube root is a perfect cube? No. It'd have to what? Be a multiple of 3. Yep. Okay. Not go into 3, but 3 has to go into it. Okay. Has to be divisible by 3. Okay. What if I'm a fourth root? Multiple of 4. What if I'm a seventh root? Multiple of 7. Okay? So when you're doing these roots with variables, you're looking at the index. Now here in number 5, the index was 2. We don't write an index of 2. We just call it square root. Okay? But in number 6, the index is 4. So I'm looking for variable exponents that are multiples of 4. If they're not, then I take the biggest one smaller than that. Okay? And I'll show you a shortcut around that too here on this one. Okay? So this would be the fourth root of 81 times the fourth root of x to the 5th times the fourth root of y to the 12th. Is 81 a perfect fourth? Yeah, of 3, right? Okay. Now, if you don't remember that, okay, you can always break that down. Well, that's going to be, let's go 9 times 9. this is 9 times 9, and 9 is 3 times 3, and 9 is 3 times 3. So since it's the fourth root, I've got to look for a grouping of 4, and I got 4 3s, so that one becomes 3. What's going on, Ben?
So, 81 is a perfect square of 54.
Correct.
That means a perfect 6.
It is not. Okay? Because there's nothing that would be multiplied 6 times to give me 81. Okay? Whereas 64 is a perfect square. It's a square of 8. It's a perfect cube. It's a cube of 4. And it's a perfect 6 because it's the 2 to the 6th also. You know what I mean? Okay? So there are some numbers that are multiple perfects. Yeah. Okay? But 81 is just square and fourth.
So 81 could be a perfect 8 because 2 times 4 is 8.
No. 81 is a perfect square of 9 and it's a perfect 4 of 3. But that's it.
Okay.
Yep. Yep. Okay. All right. So let's do the y one here now. Is this a perfect fourth? Y to the 12th. Because 12 is a multiple of 4. 12 divided by 4 is 3. So this becomes y cubed. Now, one of the things that I'm seeing, Lauren, is that people don't get rid of the radical after they do the radical. Do you understand what I'm saying there? So people would still put here the fourth root of y cubed, even though you've already taken the fourth root out. Okay? Once you do it, then you're done with it. Okay? You don't have to keep doing it. You only do it once. Okay? Oops, and I forgot the top of my 3. That's a bad looking 3 now. Let's just reset. Okay? Now, but we've got that fourth root of x to the 5th. So I can make this fourth root of x to the 5th become the fourth root of x to the 4th times the fourth root of x. Right? Okay? What's the fourth root of x to the 4th? X. So now my outsides are 3, x, and y cubed. So they all get written together. My inside is still the fourth root of x. No. Okay. Now, if that is still a little confusing for you, okay, you could always do kind of the rational exponent way, and you could say way back here that x to the 5th to the 1/4 power is x to the 5/4 power. Well, do that division. 5 divided by 4 is what? 5 divided by 4. 1 with a remainder of 1. No, 1 with a remainder of 1, right? Okay. It's 1 and 1/4, which is 1 with a remainder of 1. So you've got 1 outside, because that's the whole number, and you've got 1 inside, that's the remainder. Okay? See that? So if we had something along the lines of the 7th root of x to the 12th, right? Well, what's 12 divided by 7? 1 with a remainder of 5, right? So that's going to be x times the 7th root of x to the 5th. 1 on the outside, 5 on the inside. Okay? If it was the 7th root of x to the 22nd, what's 22 divided by 7? 3, remainder 1, so that's going to be x cubed times the 7th root of x. See that? Okay. 7. What does 7 simplify down to? No. No. Raised to the 3rd. Is 3, right? 9 divided by 3 is 3, so it's x plus 3 to the 3rd. What about 8? So just x plus 3. Okay. Questions on that stuff? Now, tomorrow you will have a formative assessment. Friday, you will have 2 homeworks due. You have the blue homework that you got on Monday, and you have the yellow homework that I'm about to hand out right now. Okay? I will tell you this. Actually, hold on. Let me pause the video because they don't need to hear this part anymore.